Hello everyone, in this video we're going to review Unit 9, Part 1 of AP Calculus BC Parametric and Vector Equations. Question 1. If s equals t squared and y equals ln t squared plus 1, then at t equals 1, d squared y over ds squared is... Alright, so the first thing you need to do is to take the derivative of this function with respect to t, right? So it could be s prime of t, right? So it could be 2t, right? Now we're going to take the derivative of this one with respect to t. So it could be dy over dt equals. We need to use the chain rule, right? So derivative of ln u is could be u prime over u, right? So this guy becomes 2t over t squared plus 1, right? Now, in order to find the second derivative of this one, we need to find the first derivative, right? So we have dy over ds equals, divide the top and bottom by dt. So we have dy over dt over ds over dt, right? Now dy over dt is going to be right here. So you have 2t over t squared plus 1 divided by ds over dt is going to be this guy, 2t, right? Now we're going to multiply the top and bottom by t squared plus 1. This guy and this guy cancel out, right? And then this guy cancel out, right? So we have 1 over t squared plus 1, right? Now we need to calculate the second derivative, which means we need to find the first derivative of this one, right? So we have d over ds of dy over ds, right? Now this guy is the same thing as d of dy over ds, right? Now you're going to divide the top bottom by dt. So it could be, now on the top we need to take the derivative of this one with respect to t, right? So it's going to be right here, right? So we're going to use the quotient rule, right? U over v prime is going to be u prime v minus v prime u over v squared, right? So this guy becomes derivative of 1 equals 0 multiplied by this one is going to be 0, right? Minus 2t, right? Times 1 is going to be negative 2t over t squared plus 1 all together square over ds over dt is given right here, right? So you have 2t. Now you're going to multiply the top and bottom by t squared plus 1 all together square. So this guy cancel out, right? This guy cancel out. So the answer is negative 1 over t squared plus 1 all together square, right? Now we substitute 1 for t into this guy right here, right? So we have negative 1 over 4, right? So the answer is A. Now let's move on to question 2. For any time t greater than or equal to 0, if the position of the particle in the xy plane is given by this guy and this guy, then the speed of the particle at time t equals 1 is... Alright, so we know that the speed is given by the formula square root of s prime of t square plus y prime of t square, right? Now we need to check the derivative of this one with respect to t. So we have s prime of t equals e to the t, right? And y prime of t equals negative e to the negative t, right? So we substitute over here, so it's going to be square root of e t squared, so it could be e to the 2t, right? Plus this one square is going to be e to the negative 2t, right? Now we substitute 1 for t into this expression right here. So we have square root of e squared plus e to the negative 2, right? Now we're going to print up the calculator. Press Control and the button right here to put square root sign, right? And e squared plus e to the negative 2. Press Control Enter. It's going to be 2.743, right? So the answer is B. Now question 3. The length of the curve determined by the parametric equation s equals sine t, y equals t for t from 0 to pi is. So in order to find the length of the curve, we need to use the formula, the integral from 0 to pi, right? Look at this one right here. Of square root of s prime of t square plus y prime of t square, right? dt. Alright, so we need to find s prime of t first. It's going to be cosine t, right? And y prime of t is going to be 1, right? So we substitute over here. We have the integral from 0 to pi square root of cosine square of t plus 1 dt, right? So the answer must be A. Now question 4. Consider the curve in the xy plane represented by s equals 2 over t, y equals ln t for t greater than 0. The slope of the tangent line to the curve at the point where s equals 1 is, right, the slope, which means dy over ds, right? So we need to take the derivative of this one first. So s prime of t is the same thing as ds over dt, right? So it's going to be negative 2 over t squared, right? And dy over dt actually y prime of t, right? So it could be 1 over t. Now dy over ds, we need to divide the top and bottom by dt. So we have dy over dt divided by ds over dt, right? So dy over dt is going to be 1 over t. ds over dt is going to be negative 2 over t squared, right? Now we need to multiply the top and bottom by t squared, right? This guy cancel out, so it's going to be t on the top. The bottom, this guy cancel out, it's going to be negative 2, right? So it's going to be the slope is dy over ds equals negative t over 2, right? Now s has equal 1. We substitute over here to solve for t, right? So we have 1 equals 2 over t, so t equals 2. Then we substitute 2 for t into this one right here to find the slope, right? So the slope equals negative 1. So the answer must be A. Now question 5. A curve is defined parametrically by s equals e to the t and y equals 2 e to the negative t. An equation of the tangent line to the curve at t equals ln is, right? So we need to find the slope first, right? So we need to find s prime of t equals e to the t and y prime of t equals negative 2 e to the negative t, right? So we need to find the slope dy over ds equals dy divided by dt over ds divided by dt, right? we just divide the top bottom by dt, right? Now we need to utilize this one right here. dy over dt is going to be right here. So you have negative 2 e to the negative t, and dx over dt is going to be right here, e to the t, right? Alright, now we're going to simplify this one. I bring this one down to the bottom, so it could be negative 2 over e to the 2t, right? Now at t equals ln 2, so the slope should be dy over dx at t equals ln 2. It's going to be negative 2 over e to the 2 ln 2, right? So remember, you have log base a of b, and then you have k right here. You can print k back over here. It's going to be log base a of b power of k, right? So I can bring 2 back over here. So I have negative 2 over e to the ln of 2 power of 2 is going to be 4, right? Now I have the formula a to the log base a of b equals b, right? In this situation, a equals e, so I have e to the ln of 4 should be 4, right? So this guy should be negative 2 over 4, and it's going to be negative 1/2, right? Now I need to find the order pair, right? I'm going to substitute ln2 for t into these two guys right here to find s and y, right? So I have s equals e to the ln 2, right? So it could be 2, right? Now y equals 2 times e to the negative ln 2. So it could be 2 times e to the pre-negative 1 back over here, right? So it could be ln of 2 power of negative 1, right? So it could be 2 times 2 power of negative 1 is going to be 1/2, so it could be 1, right? So the order pair is 2 and 1. The equation is y minus y1 equals m times s minus s1, right? So y1 equals 1. So y minus 1 equals, the slope is negative 1/2 right here, times s minus s1. S1 is right here, 2, right? Now let's convert this one to standard form by multiplying both sides by 2. So you have 2y minus 2 equals, distribute negative 1, so it could be negative s plus 2, right? So I'm going to add s both sides, so I have s plus 2y, right? And subtract 2 both sides, so it could be negative 4 equals 0. The answer must be B. Question 6. The position of a particle moving in the xy plane is given by this guy and this guy. What is the speed of the particle when t equals 2? Alright, so remember the speed is given by the formula square root of s prime of t square plus y prime of t square, right? Now this one right here, I need to find s prime of t. It's gonna be 2t plus 2, right? This guy, y prime of t, is gonna be 4t minus 6, right? So I substitute over here, so the speed should be square root of 2t plus 2 all together square plus 4t minus 6 all together square, right? I need to substitute 2 for t into these expressions, right? So I have square root of 2 times 2 is going to be 4 plus 2 is going to be 6 square is going to be 36 plus 2 times 4 is going to be 8, subtract 6 is going to be 2 square is going to be 4, right? So it could be square root of 40, right? So it's going to be 2 square root of 10, right? So the answer should be A. Now question 7. If x equals sine t, y equals cosine square of t, then the second derivative at t equals pi over 2 is, right? So again, we need to find s prime of t is the same thing as dx over dt, right? So it can be cosine t. Now y prime of t is the same thing as dy over dt. So it can be negative 2 sine t cosine t, right? We have dy over dx, divide the top bottom by dt. So you have dy over dt divided by dx over dt, right? So it could be negative 2 sine t cosine t over cosine t. So it could be negative 2 sine t, right? Now we need to take the second derivative, right? So it's going to be d of dy over dx over dx, right? Divide the top bottom by dt. So you have d over dt of dy over dx divided by dx over dt, right? Now take the derivative of this one with respect to t. So it's going to be negative 2 cosine t. Now the bottom derivative of s with respect to t, so it can be right here, cosine t. So the answer is negative 2, right? In this situation, we don't need to use this value, right? So the answer must be D. Now let's move on to question 8. A curve is parametrically defined by the equations s equals 2 cosine t and y equals 2 sine t. The length of the arc from t equals 0 to t equals 2 is. Alright, so remember you have the formula. The arc length is going to be the interval from 0 to 2, right? 0 to 2 of square root of s prime t square plus y prime t square dt, right? Now we need to find s prime of t is going to be negative 2 sine t, right? And y prime of t is going to be 2 cosine t, right? The interval from 0 to 2 square root of this one square equals 4 sine square of t. This one square is going to be plus 4 cosine square of t dt, right? So it could be the interval from 0 to 2. Factor 4 out and bring it outside, so it could be 2, right? You have sine square plus cosine square is going to be 1 square root of 1 equals 1, so you have dt right here, right? So you have 2t evaluated from 0 to 2, so it could be 4, right? So the answer must be B. Now let's move on to question 9. A particle moves in the xy plane so that at time t greater than 0, its position vector is this guy. So remember, position vector is going to be r of t equals s of t, comma y of t, right? Then at time t equals pi over 2, the velocity vector is going to be derivative of this guy right here, s prime of t, comma y prime of t, right? Now we take the derivative of this one, so we have v of t is going to be r prime of t is going to be 3 cosine 3t minus pi over 2, right? Comma 6t, right? Substitute pi over 2 for t, so you have v of pi over 2 is going to be 3 cosine of 3 pi over 2 minus pi over 2, comma 6 times pi over 2 is going to be 3 pi, right? 3 pi over 2 subtract pi over 2 is going to be 2 pi over 2, and then simplify is going to be pi. Cosine of pi equals negative 1, so the final answer is negative 3 comma 3 pi, right? So the answer must be A. Now question 10. A particle moves on the circle x squared plus y squared equals 1. Show that at time t greater than or equal to 0, its position is given by the vector right here. Find the coordinates of the point at the particle approaches as t increases without bound. So it means t approaches infinity, right? So basically, you need to find the limit of this guy right here, 1 minus t squared over 1 plus t squared when t approaches infinity. Now you're going to use the relative growth rate. This guy right here grows faster than this guy. This guy right here grows faster than this one, so you can ignore 1, right? So it could be limit of negative t squared over t squared when t approaches infinity, right? So it could be t squared divided by t squared, it could be 1, so the answer is negative 1, right? Now second one, limit of 2t over 1 plus t squared when t approaches infinity, right? We're going to use the relative growth rate, right? So we can ignore 1 right here. So it could be limit of 2t divided by t squared when t approaches infinity, right? So divide the top bottom by t, right? So it could be limit of 2 divided by t when t approaches infinity, right? It could be 0. So you have the order pair negative 1, 0, right? So the answer must be B. Now let's move on to question 11. In American football, a field goal attempt on a flat field is made when a football is kicked at an angle of 30 degrees to the horizontal with an initial speed of 65 feet per second. To score a field goal, the ball must clear the crossbar of the goal post, which is 10 feet above the ground. What is the farthest from the goal post that the kick can originate and score a field goal? Now remember, you have the formula for the position vector for a projectile. It's going to be R of t is V0 cosine of theta t I plus h plus V0 sine theta of t minus 1 over 2 gt squared. Alright, now remember g could be 32 feet per second square or 9.8 meter per second square, depending on the units right here. So the unit right here is feet, we need to use this guy. If the unit right here is meter, we need to use this guy. Alright, so keep that in mind. Now, initial speed, which means you have V0 right here, right? The angle right here, theta, right? And g equals 32. Now the initial height is 0, right? So you have R of t equals S of t, comma, Y of t, right? S of t is, it's gonna be this guy right here, right? So it's gonna be V0 is gonna be 65, so you have 65 times t, and cosine 30 degree, right? Comma, this one equals 0. V0 is going to be 65 t sine of 30 degree minus 1/2 times g equals 32, so it could be minus 16 t squared, right? Now we're going to simplify this one. It's going to be cosine of 30 is going to be root 3 over 2, right? So you have 65 t times root 3 over 2, comma, sine of 30 is going to be 1/2, right? So it could be 65 t times 1/2 minus 16 t squared, right? The crossbar of the goal post is 10 feet above the ground, which means this guy right here is 10, right? So we have 65 over 2t minus 16 t squared equals 10. Now we're going to simplify this one by multiplying both sides by 2. So we have negative 32 t squared plus 65 t, right, minus 20 equal to 0, right? So we're gonna print up the calculator. Go to the home screen, graph. So input, this guy is gonna be negative 32x squared plus 65x minus 20, and then press enter. It's gonna be right here. Alright, now we need to find the 0 of this guy, right? So we need to press menu number set number 1, go to the left, go to the right. We have the first 0 right here. Do exactly the same thing for the second one, right? We have the second 0 right here, right? So the first 0 is 0.378. Second one is going to be 1.65, right? Now, since the question say, what is the farthest from the goal, right? So we need to pick this value right here. We substitute this guy back to the S value right here to find the distance, right? So we have 65 times 1.65 times root 3 over 2, right? So we're gonna print up the calculator, go to the calculator, and then press 65 times 1.65 times control and the square root 3 divide by 2. So press enter. It's gonna give you the value 92.881. Now look at the answer choice right here. The unit should be yards, right? So we know that 1 yard is gonna be 3 feet, right? So we're gonna take this number divide by 3, right? So we're gonna print up the calculator again. Divide this guy by 3. So it could be 30.960, right? The number that closest to this number is going to be answer choice B. Now let's move on to question 12. In a major conference men's basketball game on January 21st, 1980, between Florida State and Virginia Tech, a record was set. Les Hansen, who is 6 feet 6 inches tall. So we need to convert this one to feet. It's going to be 6.5 feet. Made a basket from 89.4 feet down the court to win the game for Virginia Tech by a score of 79-77. Assuming he released the ball at a height of 6 feet 6 inches and threw it at an angle of 45 degrees to maximize distance. What was the initial speed of the ball? See the figure. Alright. So, similar to number 11, we have the formula. Now we're going to plug in values. V0 is not given, so we just leave it, right? So we have V0 cosine of the angle right here, 45 degrees, right? Cosine of 45 degrees, right? I put T right here. Comma, the initial height is right here, which means the height of this person, right? 6.5. So we have 6.5 plus V0 sine of 45t. So I put t right here, right? Minus 1/2 g. Now, in this situation, we look at the unit right here. It should be feet, right? So we need to use 32 instead of 9.8, right? 32 divided by 2, it could be 16. So we have 16t squared, right? Now we're going to simplify. So it could be cosine of 45 is going to be root 2 over 2. So you have root 2 over 2 V0t, comma, negative 16t squared plus root 2 over 2 V0t plus 6.5, right? Now we need to use this information right here. It's going to be 89.25 feet. This guy actually the value of S of t, right? So we substitute over here. So we have root 2 over 2 V0t equals 89.25, right? So then V0 t equals 89.25. Multiply both sides by 2 over root 2, right? So this guy times 2 over root 2, right? Now divide both sides by V0, so t equals 2 divided by root 2, it could be root 2, so it could be 89.25 times root 2, right? Divided by V0. Now we have this information right here. This guy actually y of t, right? So y of t equal this guy right here, right? So we have negative 16 t squared plus root 2 over 2 v0. Now t right here, I'm going to use this guy right here, right? So I have 89.25 over v0 times root 2, right? Plus 6.5, right? This one equals 10 right here, right? Now v0 and v0 cancel out, right? Root 2 times root 2, it could be 2. 2 divided by 2 cancel out, right? So I have negative 16t squared plus 89.25 plus 6.5 equals 10, right? Now I'm going to subtract 89.25 and 6.5 both sides, so I'm going to end up with negative 16t squared equals negative 85.75, right? So then t squared equals 85.75 divided by 16, right? So t equals square root of 85.75 over 16, right? We're not going to take the negative number, right? So we're going to print up the calculator. Control the square root side right here. 85.75 divided by 16 is going to be 2.315. Now substitute this guy over here to solve for V0, right? So V0 equals 89.25 root 2 divided by 2.315, right? So we're going to print up the calculator again. Now we have 89.25 times square root of 2. Press enter. Then we need to divide by this guy right here. And then press Ctrl enter. It's going to be 54.513. So the answer must be D. Now let's move on to question 13. A curve C is defined by the parametric equation, this guy and this guy for t greater than or equal to 0. Find dy over ds in terms of t, right? So we need to find ds over dt first, right? Now we can rewrite this one so that we can use the power rule, right? So we have t plus 1 power of negative 1/2, right? So ds over dt is going to be negative 1/2, right? Times t plus 1 power of negative 3/2, right? And then it's going to be negative 1 over 2 times t plus 1 power of 3/2, right? Now dy over dt equals, we're going to use the quotient rule, right? Divided over this one equals 1, so it could be t plus 1 minus divided over this one is going to be 1, right? So it could be minus t over t plus 1 altogether square, right? So it could be 1 over t plus 1 square, right? Now dy over ds, we just divide the top and bottom by dt, so we have dy over dt divided by dx over dt. So it could be dy over dt is could be right here. So we have 1 over t plus 1 altogether square divided by negative 1 over 2 times t plus 1 power of 3.5, right? We're going to multiply the top and bottom by 2t plus 1 power of 3.5. Alright, so it's going to be this guy cancel out, right? You have negative 1 right here. So it could be negative 2. Now, this guy and this guy cancel out, so it's going to be t plus 1 power of negative 1/2, right? And it's going to be negative 2 over square root of t plus 1, right? Now, question B, find an equation of the tangent lines to C at t equals 3, right? So we substitute 3 for t over here to find the slope, right? So the slope is negative 2 over square root of 3 plus 1. It's going to be negative 1, right? And you're going to substitute 3 for t into this guy right here to find the order pair, right? So you have s equals 1 over square root of 3 plus 1. It's going to be 1/2, right? Y equals 3 divided by 3 plus 1. It's going to be 3 over 4, right? So equation y minus y1 equals m times s minus s1. Substitute, so y minus y1 is going to be 3, 4 right here. Equals the slope is going to be negative 1. So minus s minus s1 is going to be 1/2 right here. Alright. Now question C, set up but do not evaluate a definite interval representing the length of the curve C on the interval 0 to 1, right? So remember you have the formula, the length equals the interval from 0 to 1 square root of s prime of t square plus y prime of t square dt, right? Now if you square this one, it's going to be s prime of t square. It's going to be 1 over 4 t plus 1 power of 3, right? So we're going to put it right here, square root of 1 over 4 times t plus 1 cube plus y prime of t, we got it right here. This one square, so it could be 1 over t plus 1 power 4 dt, right? Now question D, find an equation for the curve C in terms of x and y, right? So we go back over here, x right here, y right here, right? We copy this one down. Now for this equation, we need to solve for t, right? So we square both sides, so we have s squared equals 1 over t plus 1, right? So t plus 1 equals 1 over s squared. Then t equals 1 over s squared minus 1. Substitute this guy for t into the function y right here. So you have y equals 1 over s squared minus 1 divided by 1 over s squared minus 1 plus 1, right? Now it's going to be 1 over s squared minus 1 divided by 1 over s squared, right? Now you're going to multiply the top and bottom by s squared. So this guy cancel out, right? This guy cancel out, so it could be 1 minus s squared, right? Then you need to put y right here, and this is the final answer. Now question 14. For t from 0 to 5, a particle is moving along a curve so that its position at time t is this guy. At time t equals 1, the particle is at position 2, -7. It's known that dx over dt is this guy and dy over dt is this guy. Write an equation for the line tangent to the curve at the point 2, -7. Alright, so you need to find the slope first, right? So we have dy over dx, right? Now you need to divide the top bottom by dt, so you have dy over dt divided by dx over dt, right? Dy over dt is going to be right here, so you have e to the cosine t divided by sine of t divided by t plus 3, right? Now t equals 1, substitute 1 for t, so you have dy over dt evaluated at t equals 1 equals e to the cosine of 1 divided by sine of 1 over 4, right? Now we're gonna print up the calculator. So make sure your calculator in the radian mode, right? So you have e to the cosine of 1 divided by sine of 1 over 4. Then press Ctrl Enter. It's going to be 6.938. Now you need to find the order pair. Now the order pair is given right here, so we don't need to find, right? So we have y minus y1 equals m times s minus s1, right? So then y minus -7, so it could be plus 7 equals, the slope is going to be 6.938 times s minus 2. This one is the final answer. Now question B. Find the y-coordinate of the position of the particle at time t equals 4. Now we need to use the fundamental theorem of calculus, right? So we see that dy over dt is right here, right? So we have the final position y of 4 equals initial position is going to be right here, right? Y of 1 plus the interval 1 to 4 dy, right? Now y of 1 is -7 right here, right? So you have -7 plus the interval from 1 to 4, right? Now dy, we got it right here. We just multiply both sides by dt, so it could be e to the cosine t dt, right? Substitute this guy over here, so you have e to the cosine t dt, right? Now we need to print up the calculator. So we have -7 plus, hit the button right here, the interval right here from 1 to 4, e to the cosine t dt. Press Ctrl Enter. It's gonna give you -5.00667, right? Question C. Find the total distance traveled by the particle from t equals 1 to t equals 4, right? So we have distance equals the interval from 1 to 4 of square root of s prime of t square plus y prime of t square dt, right? Now we substitute values, so we have the interval from 1 to 4. S prime of t is right here, and y prime of t is going to be right here, right? So we have, now we're going to print up the calculator. I'm going to copy this one over here. I just changed the number. This guy should be 3, right? And then press Ctrl Enter. It's going to be 2.469, right? Now let's move on to the last one. Find the time at which the speed of the particle is 2.5. Find the acceleration vector of the particle at this time, right? So the speed equals 2.5. You know that the speed is given by the formula square root of s prime of t square plus y prime of t square, right? And then it's going to be square root of sine of t over t plus 3 altogether square plus e to the cosine of t altogether square, right, equals 2.5, right? Now we're going to square both sides, so we have sine square of t over t plus 3 plus e to the cosine t. When you square, it's going to be 2 right here, right? Equals 6.25, right? Now we're going to wrap these two guys on the graphing calculator and we're going to find the intersection, and that's the answer, right? So we're going to print up the calculator. Go to graph right here, press tab, go to y1, clear this one. It's going to be sine of t over t plus 3, right? So it could be, then press enter, it's going to be right here. Now we're going to press tab, y2 is 6.25, press enter, it's going to be right here. Alright, now we need to find the intersection. Remember, we need to restrict the domain. The domain is t from 0 to 5 right here. Alright, so we're gonna press menu, window, zoom, window setting right here. As min is 0, as max is 5, right? And then press enter, it could be right here. Now we couldn't see the intersection on the right hand side, so we need to go to menu, window zoom, window setting right here. We just put as mask like 7. Alright, press enter, it's gonna be right here. Now remember the domain is from 0 to 5, right? Now we need to find the intersection, so we need to press menu, analyze graph, intersection. Go to the left, go to the right, it's going to be 0.415. And the second one right here, menu, analyze graph, intersection, it's going to be right here. Now, remember the domain is from 0 to 5, right? This one is 5.8, is outside the domain. So we only have one solution, 0.415, that's it, right? Now, the acceleration is the second derivative of the position, right? So which means we need to take the derivative of this guy right here, right? So we have a of t equals s double prime of t comma y double prime of t, right? So basically we need to take the derivative of this guy right here, right? Since we are allowed to use the calculator, so I just store this function as u of t and this one as v of t, right? And then I'm going to take the derivative of this one, right? So I'm going to print up the calculator, right? So I have u of t is going to be right here. And then press Ctrl the button right here. And then we just input the function, right? So we have sine of, put a fraction, t over t plus 3. And then press enter. Now V of t, press Ctrl the button right here. It's gonna be e to the cosine of t, right? And then press enter. Now we need to take derivative of these two guys and evaluate the value of the function at t equals 0.415, right? So we're gonna press this button right here. Then we're gonna hit this guy right here. Alright, so this one should be t. Right, this is u of t. Then you go to the right, you need to press Ctrl equal sign, put the line right here. You put t equals 0.415 and then press enter. It's gonna give you the value 0.2553, right? Now we do exactly for the bottom one, right? So the v of t, right? And then press enter. It's gonna give you negative 1.0079, right? It's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.